and see what we've done and what we still need to do. So the first important thing is the distance formula. We have done all these things. It does say prove that a quadrilateral is a parallelogram with a distance formula, but all you would need to do for that is, if you are trying to prove something is a parallelogram with the distance formula, you just need to prove that the opposite sides are equal. Now, it's easy enough to do. You just find the distance here and here and here and here. It's not my recommended way of proving something's a parallelogram, but if you have to do it, you just use the distance formula. So the distance formula is one thing that definitely we've covered. Then we talk about gradient. And as we look at that, we've spoken about parallel lines, perpendicular lines, how to show something is right angled. So we've done that. We've done quite a lot here, sure. Angle of inclination, we did that. Okay, determine whether a quadrilateral is a parallelogram. Now, I'm going to focus on this a little bit today, and I mentioned it in the last lesson, but the quickest way to show something's a parallelogram is to show that the diagonals have common midpoints. So I'll say here, you need to show that the diagonals have common midpoints. And if you do that, then you've proved that oh, lots of people are coming in now. Let me just let them in. And then I will get back to the lesson in a moment. If you show that the diagonals of a quadrilateral have common midpoints, you then know that the diagonals cut each other in half, or the diagonals bisect, and therefore it's a parallelogram, which I will show you again today, but we showed that at the end of the last lesson as well. We also, if there's time, talk about what it means for something to be collinear. So collinear just means that the points, 3 points are collinear if they are on the same straight line. Whereas if I talk about these 3 points, they are not collinear because the 3 points are not on the same line. So collinear just means on the same line. For bonus points, I know we haven't done this, but for bonus points, how would we show 3 points are on the same line, or that they are collinear? I'm just curious to ask in the class, does anybody know how you would prove that 3 points are on the same straight line, or collinear? Pop your hand up if you feel you have some insight. Otherwise, I will share that knowledge with you, and then you can practice it later in the lesson. Let's have a look. Gradient. Yes, Dylan, Bukle, you're quite right. So if you want to show 3 points are on the same straight line, let's say they're the points A, B, and C, you just find the gradient from A to B, and you find the gradient from B to C. And if their gradients are the same, they are therefore collinear. So it's actually quite simple. Like basically, if you have 3 points and you want to check if they're collinear, you just choose like 2 of them together and you find the gradient, and then you choose 2 other ones, you find the gradient of those 2. If the gradients are the same, they're collinear. If they're not the same, they're not collinear. So it's not super hard, and we'll do an example later in the lesson, but it's quite nice just to go over all the key ideas from the section. Then the other one that's important is the midpoint. So can you find the midpoint? And we spoke about the midpoint of a line segment, find the length given 1 point, and then also the angle of inclination, the angles in a triangle. And then the last bit is just basically how to find the equation of a straight line. So there's 5 major ideas. We need to maybe top up a little bit on these 2, but otherwise I'm feeling like we've covered pretty much all the important stuff. Give yourself a score out of 10 for how well you know the stuff that's on the board. 10 would be like perfect, 0 would be like nothing, 5 would be sort of okay. Give yourself a score out of 10 for this content. And then we're going to work at getting you even higher by the end of today. Okay, cool. Now remember, we've still got the whole of this lesson to keep you swimming, so let's get started. All right, here is a question about a parallelogram. But the question doesn't actually say prove it's a parallelogram. It says state the coordinates D so that ABCD is a parallelogram. Give me a thumbs up if you've seen a question like this before. Give me a thumbs down if you've never seen a question like this before. I want to get a feel for if you've seen a question like this. Okay. So whenever they give you this order and you're trying to find a missing point, the missing point must go in the order that they gave it to. So if I go A, B, C, I can't put D down here. D is actually going to have to be up here somewhere. Because if I don't put D there, I won't be able to keep the order of A, B. So A, B, C, and then the last thing is D, and then I can start again. So the first thing to know is that we need to keep the order of this original thing. Now, one of the properties of a parallelogram is that opposite sides are parallel and opposite sides are equal. So in some ways, if you had to imagine, I know this is not the greatest drawing in the world, but this parallelogram I'm trying to figure out, I don't know what D is, but I'm going to assign it the coordinate XY because that's what I'm trying to figure out. That's the whole point. Find D such that ABCD is a parallelogram. Now, because this side, the black lines are parallel to each other and equal, we can use that property to help us. So let me take you on a journey. Let's pretend we are stuck down here at B. So I'm going to give B the coordinate XY just because it's a general coordinate. I know it's a bit, there's an XY up here, but, whatever. I want to know how much do I go across to get from B to C, and how much do I go up to go from B to C? So X changes in a certain way to go from -2 to 5. How much does the X change? And how much does the Y change to go from B to C? I want you to put in the chat. How much does it change? If I was at -2 on X and I was at 5 in C, I think it increases by 7. And so what I'm going to say is the journey from the red dot to X is going to be X plus 7 because that gets me from -2 to 5. I want to know how much does the Y value have to change as I go from the red dot, let's say, to the green dot. And I want you to try and put that answer in the chat. So you were at 0 over here, you're now at 3, and so my Y value must increase by 3. Okay, so here's the good news. The journey from the red dot to the green dot is to go across by 7, or plus 7x, and plus 3y. But now what I'm going to do is I'm going to start my journey from A. And the point A is 0, 6. But because this is part of a parallelogram, it's going to go on the same journey. And so in order to get the point D, I'm going to go 0 plus 7, and then I'm going to go 6 plus 3, because that's the same journey that I went on from B to C. Can you tell me what the point D is that makes ABCD a parallelogram? Can you tell me what point D has to be? So 0 plus 7 would give me a 7 there. And what is the second one? It's going to be 9. So to recap this idea, if I want to find a point that completes a parallelogram, I first have to put the mystery point in the right place. And the right place is the place that preserves the order A, B, C, D. Then I give it X, Y, the mystery value. And then I say, what is the journey from one side to the other? And I describe that journey with some notation. And then I repeat that journey after that. There's a question there. Let me go to the question. Bukle, what is your question?
So I wanted to ask, is this the conventional way to like answer a question like this? Because we did it in school, but our teacher used this other method. It's so confusing. But now I see Sid
Okay.
has done it so simple. I'm not sure if it's the way
Yeah.
to do it in
Okay.
exam.
All right. So here's the thing. Brooklyn, there is a harder way of doing this, but obviously I'm showing you the easiest way. The way that your teacher may have done it is they may have said, find the equation of this line, the green line, find the equation of the other line, and find the intersection point, right? You can
Yes, sir.
do it like that, but it takes so long, whereas this method is so quick and efficient. I think, and it makes a lot of sense because you're using the property that the opposite sides are parallel and equal. So there are harder ways to do it, but this will get you full marks. So, my thinking is, why do that,
Okay.
Cool. But you're right to ask. Thank you for that question, because there's probably a couple of people who were thinking that. Let's do another one here. I want you guys to try and fly solo this time. So I will give you a hint though. It says, determine the coordinates of H such that ABCH is a parallelogram, but I have to preserve the order. So I have to go from A to B, which is there, to C. The only place H can be is out here. Because some people will say, call H here or H here, but I have to preserve the order. So I'm going to help you out. I'm going to help you by putting the point there. And then I know it doesn't look like it because visually it's not to scale, but I want you to try and find me the point H. And if you get stuck, I want you to raise your hand and ask questions, but see what you can do to find me the point H such that H completes this parallelogram. I know my H is not, it's a horrible H. It's not drawn to scale, but you can do it. You can do it. So choose 2 points to focus on to go on a journey. I was thinking of focusing, you don't have to focus on these two, but how do I go from B to A? And then you use that to help you to go from C to H. You could have done it by going from B to C as well. It doesn't matter. And pop those hands up if you have a question. So going from that to that would be X plus 8. So minus 2 to 6. And then from 2 to 4 would be Y plus 2. If I'm at 6 minus 2, what would my point H be? So everyone, the method that I'm using is going from here to here must be the same as going from here to here. And that's because even though they don't look it, these are equal and parallel. So I want to know, what is the answer we are going to get for H? Ooh, did I make a mistake? 6 minus 2, no, that's fine. So 6, this is going to be, if I need to go plus 8. So that's going to be 14. So that's why it looks so weird. My point looks so weird because it should be much further along. So let me even do this. Then it will start to look more like a parallelogram. So what is my Y value that's going to go with this? Oh, is it if I go -2 + 2, I get 0. So actually, if I was being perfect, that is where, oh, that looks more like a parallelogram as well. So the point H would be there, and that looks much more like a parallelogram. So just to point out what I was doing, I was saying, look, to go from C to here, I needed to add 8 to whatever the x was here. So 6 + 8 is 14. And then I went from -2 and I added 2 and I got 0. I want some questions because I think a lot of students might be feeling a bit confused. So pop those hands up or give me a score out of 10. Like if you understood that perfectly, give it a 10 out of 10. 5, you sort of got it, but not quite. 0 if you were completely confused. I just want to feel for how everyone is, if they followed that journey. Okay, we're going to do another one now. So just, are there any questions? You just pop your hand up. You know that you can actually ask live questions here. Hey? So you just pop your hand up and I can come to you. Otherwise, we'll just do another example. But the key step was, it's almost like you need to plot the route. So going from yellow to the green one, I was basically just figuring out how to go from the one side to the other. Then what I did was I said, look, I'm starting life at the pink one, and using the route I got from going from yellow to green, I can get to the blue point. And I'm using what I learned above to help me get there. That's kind of what's going on. Let's do this one. Okay. If PQRS is a parallelogram, find the coordinates of R by inspection. So, you know, Bukle, you were asking me, you can find R by inspection, which is kind of what we're doing, or you can use simultaneous equations. If you use simultaneous equations, you would basically have to find the equation of that line. You'd also have to find the equation, no, sorry, you'd have to find the equation of this line, and you'd have to find the equation of that line. And where they meet, you'd find R. But that would take a bit of time. So that's why I'm suggesting by inspection. Now, what we need to do is choose the route we're going to use. Now, we can either choose to go, tell me in the chat, do you want me to use going from P to S to help me get from Q to R? Or would you prefer me to go from P to Q to help me go from S to R? You tell me which one you would prefer. Would you prefer me to use blue-green or blue-yellow to help get to R? Tell me in the chat which one you want me to use. There are two choices. They both will work. But I just want to show you that they both will actually work. All right. I'll go with the one that has the most votes. Okay, P to Q is winning at the moment. So I'm going to choose P to Q. So I'm going to pretend I'm at P. And to get down here, I need to go, what happens to X? X has to actually has to subtract 1 to go from there. And to go from 3, I have to go subtract 2. Because I go in from 3 to 1. So this is the route I take. But instead of starting at P, you're now going to start at S. What are we going to get for the mystery of value? So you can use whatever way you like as long as we get this answer. So if I'm starting at 7 and the root is to take away 1, so I'm at 7 and I have to take away 1, that would be 6. And then if I am at 5, what was the rule said? It said take away 2 from y. So this 5 minus 2 would be 3. Oh, it's not really different from the previous one. I'm still it's still the same method. I could have used blue to yellow to guide me to go from green to R, or like I did, I went from blue to green to get my rule, and then I used that rule to help me get R. All right, so this is called finding the missing point to form a parallelogram. But sometimes the question will be this. It won't look like that. The question will look like this. They will give you 4 points of a quadrilateral, and they will say, prove that PQRS is a parallelogram. And there's a couple of different ways you can prove something's a parallelogram. The one way is to find the distance here, the distance here, and the distance here and the distance here using the distance formula. And if you show the opposite sides are equal, it's a parallelogram. It works, but it takes a long time. Another way you could do it is by showing that the gradient of these two is the same and the gradient of these two is the same. But that also takes a bit of time. It's not wrong to find the gradient. It takes time. The quickest way to prove this thing is a parallelogram is to say, what is the midpoint of the diagonal here? And what is the midpoint of the diagonal over here of this quadrilateral? And see what happens to those midpoints. So I want you to calculate for me the midpoint of PR, and I want you to find me the midpoint of QS. Now remember, this is a different question. We don't know that this is a parallelogram yet. We're trying to prove it, and the way we're doing is we're examining the diagonals. So find me the midpoint of those two diagonals, please. So how does the midpoint formula work again? We add, so P and R, so minus 2 plus 6 over 2, 3 plus 3 over 2. So the first midpoint I get 4 over 2, so that's 2, and this is 3. Okay, so the midpoint of the first one is 2, 3. What's the midpoint of QS? Give me some time to work that out. Oh, also the same. Interesting. Let's see. Minus 3 plus 7 over 2. 1 plus 5 over 2. Which is 4 over 2, which is 2. And then this is 3. So therefore, common midpoints for diagonals. Okay, so what that means is that there's a point here which cuts, the diagonals aren't the same length, but there's a point which cuts them in half. And so we can then say, therefore, PQRS is a parallelogram. And we can just say because the diagonals bisect. That's it. Now, is it wrong to use the distance formula or to use gradients? No, it just takes longer. And I obviously try to teach you the quickest way so that you have extra time for other subjects, essentially, or other areas. Give me a score of 10 for how you're understanding the missing point and proving something's a parallelogram. 10 would be like very good, perfect understanding. 5 is sort of okay, but needs to improve. 0 would be nothing. Give me a score of 10 for how you are feeling about this. Okay. Let's just do one more of these questions before, keep those votes coming. So in the previous question, I want to just prove So I'm going to do a similar example from the original one that we did. So I'm going to get rid of all the extra bits. And I'm going to pretend, I'll put it up here. So I'm going to modify this question so it allows us to practice something else. So I want you to ignore what they say here. I'm making a new question. I want you to prove that A, B, C, D is a parallelogram. So when you're finished with that, just say done in the chat. But I want you to try and prove that A, B, C, D is a parallelogram using whatever methods you like. And then after that, we are going to have a break. Ooh, there we go. Prove that A, B, C, D is a parallelogram. And I'll give you the hint that that's one diagonal and that is the other. And I apologize for my horrible drawing. I'm just trying to get extra value out of my questions today. Okay, so step one, find the midpoint of AC, then find the midpoint of BD. And just say done in the chat when you're done. Then I know. Interesting. That's okay. So I see that there's a common midpoint, which is 5/2, 9/2. And I work that out using the midpoint formula. Once I've established that, I can say that that is a parallelogram because I know that the diagonals bisect each other. Now, and again, if you look at this, the diagonals are not equal length, okay? In fact, the green one is clearly longer than the red one, but basic idea is there. All right, everyone, it is time for a break. So what I want us to all do is I want us to stand up. And we've done a solid 35 minutes of work. So let's just start with a little relax, some deep breaths. We're just trying to get some oxygen back into our brain so that we can function. And then let's just sort of loosen up. We can shake our hands out a bit. So shake out your hands. It's quite nice. It actually feels quite, yeah. And then shake out your legs. And then let's roll our shoulders. Roll them forward. Let's stretch our neck out. I feel my neck feels a bit stiff today. Oh, lots of clicks. Okay. Stretch your neck out. And then let's just do some small little shoulder rotations. Going forward. And then let's go backwards. So we're just trying to wake our body up now. Like, your body kind of can sometimes go a little bit to sleep. And that's not good for learning. All right, and then last thing is let's just do some jumping jacks, and we're going to do 10 of them in 3, 2, 1. Let's go. 4, 5, 6, 7, 8, 9, 10. And yeah, I don't know about you, but I'm definitely feeling like my body and brain appreciated that. And then let's just do a little puzzle to help us out. Looks a bit like a Halloween puzzle, doesn't it? So there is what is that? A salamander, something, a pumpkin and some bats. Maybe it's some sort of frog, who knows? Find me what a pumpkin plus a bat times, I don't know what that is. But anyway, find out what that is for me. So, Naledi, I agree. This creature is 10. What's a pumpkin worth in the story? Oh, Naledi, you're on it. Actually, this is not so bad. Pamela, let's have a look. 1, 1, 1, 1, 1. Be careful though, because the bats here are occurring in twos. And so each bat is worth 1, which means that is a 1 bat. So, Anushka, what do you think the final answer is? Well, according to BODMAS, so we've got this, right? But according to BODMAS, that must get done first. So it would be 5 plus 10, which is 15. So it is indeed 15. The 6, I understand why some of you are getting 16, but the reason it isn't is each bat is worth 1. And so in this line, even though this collection of bats is worth 2, each individual bat is worth 1. And there's only 1 bat here. All right. Let us return to our journey for today. Okay, so let's have a look. Hence show that ACR is a parallelogram. I think we've done enough proving of parallelograms. Let's do this. Sometimes you have to find a point using simultaneous equations, or graphically you have to observe it. So it says, the diagram shows the lines 3x plus 2y minus 12. So that would be this one over here. And then it also shows the line y equals x minus 1. Use the diagram to solve the simultaneous equations. Which of the options is correct here? Now, you don't have to do the algebra. I'm going to do the algebra anyway, just to show you. But which of the options do you think is correct for finding this point over here? Or to solve the simultaneous equation? So when you have two lines that meet, they are the simultaneous solution for this. So what the question is actually asking is, what is the x value? Oh, let's have a look. I must disable annotation. There we go. So if that goes to that, and that goes to that, what is that blue point going to be? Which of the three options here represents that blue point here? So if x is -2 and y is -3, it's going to have to be this one over here. Yes. Now, just to show you how this would work in algebra, this is more of a simultaneous equations idea from earlier in the year. But if you have these two equations and you want to find a simultaneous solution, what you do is you take the easy equation and you sub it into the harder one. So, for example, if I took 3x plus 2 times whatever y is equals -12, what I'm going to do is I'm going to put x minus 1 in there because that comes from this equation. And then once I sub the easy equation into the hard one, I'm going to get that. And then I'm going to get 5x equals, so that becomes a +2. So -12 plus 2, which is -10. And then x is -10 over 5, which is -2. Now, if you look at what the graph gave us, it was that x is -2. So you can find the intersection point or the simultaneous solution of two lines by either visually looking at where two lines cross and reading it off from the graph, or you can use simultaneous equations. You may say, but what about the y? Where do I get the y from? Well, isn't there an equation which says y equals x minus 1? So you said you had x of -2. If you take away 1, you get -3. And so you find that that's -3 using algebra, but you can also see it's -3 using the graph. And so this is an idea that sometimes comes up in this section, is that you need to understand that where two lines meet, the intersection point is the simultaneous solution. And so some of you might need to practice this a bit on your own time. Give me a score out of 10 for how well you understand this type of question, a simultaneous equation / intersection point question. And be honest, because it depends, it affects how many examples I do after this. Okay. All right. Oh, this is a bit of a harder one. Do I want to do this one right now? Probably not. Okay, let's do it. It's a bit harder, but let's do it. Okay. Which diagram shows the graphical solution to this these two equations? What I would say is that the one is very easy to see. The other one is a bit harder. But let's just use the yellow one. Since the y-intercept here is 6, I'm going to cross this one out straight away. Oh, wait, no, maybe I should be careful because that might be up here. You know what? I need to change this into standard form. Can you please do that for me? Change this line into standard form and tell me in the chat what you get. And that will help me figure out which drawing can show the graphical solution of these two lines. So I want to know, what is the standard form of the straight line I circled with the red? So what I need to do now is take the x to the other side, and I'm going to get 3y equals minus x plus 6. And if I divide both sides by 3, I'm going to get minus 1 over 3x plus 2. Okay, now what I'm going to use to help me is I need one line that has a negative gradient, but a y-intercept of plus 2. And then I need another line that has a y-intercept of 9, but a positive gradient. Which of these 4 options matches those 2 straight lines? I'm going to cross out that one because it can't work. For this one, this can't work either because I need 2 and 9. So it's either going to be A or B. Because look here, you need to have plus 9 and plus 2. Look at the y-intercepts. So it's either going to be A or B. It can't be, sorry, A or C, not, sorry, A or C, A or C. Now, I need the one to have a gradient of 2. So this goes 1 across and 2 up. So that's fine. This one over here has a negative gradient, and it goes up. So because this has a negative gradient, it has to go with this one over here, but it's not going through at plus 2. So I'm crossing this out. The correct answer, and this was a difficult question, is A. So I'll point out why this is. We can see, okay, we can see that the green line has a negative gradient, and it's going through plus 2, which is going to relate to this graph here. The purple one has a very steep gradient, but it's not that steep, sorry. It's a gradient of 2, but it has a y-intercept that goes way up here, which fits with the idea of being a plus 9, which is over here. Now, that was a properly tough question, but just give me a sense, give me a thumbs up if you followed my explanation. Give me a thumbs down if you didn't. I think most of you probably didn't follow it, but you can always rewatch my thinking. It was a tough question, I know. It was a tough question. But I don't want you to stress. You're not going to get a question like this in your thing, so it's fine. It was too interesting to just go by. Can I suggest you guys rewatch just this part of the video? I don't want to get stuck on this now, but if you rewatch it, it'll make a bit more sense. Okay, let's finish with one more thing today. I want to finish with collinearity. So I want to know, are the points 1, 1, 3, 5, 3, 5, and 6, 6, are they on the same straight line? Are they collinear? So are A, B, C collinear? And the way that we would do this is we would find the gradient between A and B, and we'd find the gradient between B and C, and then we'll make a decision. So find me the gradient between each of those points. Find me the gradient between each of those points. Remember the gradient formula. So 5 minus 1 is 4, 3 minus 1 is 2. So the gradient here is 2. the gradient for BC is 6 minus 5 over 6 minus 3, which is 1 over 3. Are the points A, B, C collinear? Yes or no? Based on what I said earlier in the lesson. Are these 3 points on the same straight line? No, as MAB does not equal MBC. So A, B, and C are not collinear. The gradients would have had to be the same in order for them to be collinear. Okay, let's do one more like this. If I gave you the points D, E, F, and the points here are 1, 1, 6, 6, and 9, 9. Are D, E, F collinear? So work out for me, are D, E, and F linear? Are they on the same straight line? And then we're going to call it a day for today, I think. So what should you do first? Right. What I'm seeing is that D, E, and F are collinear as M of DE is equal to M of EF. They both equal the gradient 1. Yes, Anushka. I made that up just to make sure that they were collinear. I just made that question up, so I was just playing it very safe. Yeah. All right, everyone. So that concludes our unit on analytical geometry. I will